Alright, so we're going to continue solving quadratic equations. In these next sets of videos we're going to be doing two techniques of solving. One is solving by completing the square. Alright, so we're not going to factor, we're not going to extract square roots, we're going to complete the square. Alright, so first thing you need to know is that in all the examples we're going to work on, a is 1. The coefficient on x squared is 1. If it's not 1, it gets a little more complicated, so I think we're going to avoid where a is not 1. We're just going to focus on where a is 1. Alright, and the second thing you need to know about is that when you solve by this method, you don't put the equation in general form. Obviously, this equation is presented to us in general form, so we're going to have to do some changes. So be patient as we go through these. These are a little bit different. So we'll do a couple examples to get the feel for it. Alright, solving by completing the square. I mentioned we don't put it in general form, so what do? We actually take the constant only and move it to the other side. And I know we're almost tempted to take out a factor here, but that's not what we're going to do. We're not going to pull out an x. As a matter of fact, we're going to bring down x squared plus 2x, and then we're going to leave a little blank here. Equals 6. Okay. So what we're trying to do is we're trying to put a constant here, a number, such that when we put that number there, we're able to factor this trinomial. Once we get this constant here, these three terms, we're able to factor it into a binomial square. This is a binomial, and this is a square. So that's the target. So how do we find the constant that we put in here that allows us to factor this trinomial into a binomial square? Okay, well, what we do is we take half of b, so maybe put a note over here to yourself to find the blank. We're going to take half of b, and once we get half of b, we're going to square b. Well, b is 2, so half of b is 1. And when we square 1, we get 1. So we're going to add 1 here. That's our constant. That's going to allow us to factor this into a binomial square. Alright, well what we just did is we just added a 1 that wasn't in our previous line or even in our original line. So if we're going to add a 1 to the left side of the equal sign, we're going to have to come over here and add that same value over here. So now we've balanced the equation again. It's checking our work. If we were just to take away these two ones, we'd get back to the previous line, which we've maintained equality. Alright, so then what do? Well, the next move after we create what we call this trinomial square, if you were to factor this, it actually factors into x here, because both of the binomials, if we were to expand this, would have to have an x in the first position to multiply and give us x squared. And as a matter of fact, we take half of the b value before we squared it, half the b value which happens to be 1, and we put the 1 here. So half of positive 2 is positive 1, so we fill up our binomial with positive 1. If you were to take and expand this to check your work and multiply out quantity x plus 1 times quantity x plus 1, you're going to get back to this trinomial square. Alright, so we're going to come over to the right hand side of the equation and do the computation and get 7. So if you think about our second technique for solving quadratic equations, we extracted square roots. So we've actually just created a binomial square that we can now use the easy technique of extracting square roots to solve. So we completed the square so we could use extracting square roots. So picking up kind of with that last technique, I'm going to rewrite the problem. I'm going to bring in the square root on both sides of the equation. Square rooting a square results in us getting x plus 1, but remember it's an even power, even root, so we bring out the absolute value of x plus 1 and bring down the square root of 7. Alright, what next? We remove the absolute value, adjusting for a positive negative, To get x by itself, we're going to have to subtract a 1 from both sides. So when you subtract a 1 here, let's not put it behind the plus minus. Common practice has us put it up front. We're finished. These are our two solutions. But sometimes it's good to see them written out separately. So negative 1 minus the square root of 7 would be the smaller number, and negative 1 plus square root of 7 would be the larger number, if we wanted to put them in order. All right, let's complete the square again. So example 2. All right, this wouldn't factor even if we wanted it to. So sometimes factoring doesn't work, but completing the square always works, as does quadratic formula in solving a quadratic equation. So the two techniques that will always work would be completing the square and quadratic formula, which will be next. All right, we're going to solve this by completing the square. All right, so it can't be in general form, so the first thing we're going to do is we're going to add the constant to the other side. Okay, again, you're probably tempted to pull out an x, but that's not what we want to do. We got this constant out of the way so that we could leave a blank here to put a number that's going to allow us to factor this trinomial into a binomial square so we can extract the roots. So nothing's changed. I'm just changing the structure of the original problem. Okay. At this point, we want to find out what goes in the blank, what constant, and we take half of b and we square it. So half of b is negative 2. You square it, you get positive 4. Well, positive 4 wasn't on the line previous, so if we're going to add it to the left side of the equation, we've got to come over here and add it to the right. We have to maintain equality. All right, now it's time to factor. The whole reason we put that number there is so that we could factor into a binomial square. So it would have to be that I'd have x up front. And to get this term, we'd look at half of b. Half of b was negative 2, so we put minus 2 in here. You could check your work by foiling, boxing, distributing, putting these out two side by side, working it out, and you should get back to this trinomial. Move over to the right-hand side of the equation, do the computations. Now from this form, we can extract the roots to find solutions. Bring out the absolute value of x minus 2. Bring down the square root of 5. Rewrite without absolute value, making the adjustment of the positive negative. Isolate x by adding 2 to both sides. We usually don't put it behind the root, or the plus minus I should say. We usually put it up front. So 2 plus minus square root of 5. So if you wanted to write your solutions out separately, the smallest one would be 2 minus radical 5, and the larger value would be 2 plus radical 5. And by the way, I have checked all these solutions and they all work. Alright, just one more for the sake of extra practice. Let's look at this one. Okay, we've been directed to solve by completing the square. Notice the equation is not in general form, so it's actually ready for us for completing the square. The constant is on the right-hand side of the equation. So what we're looking for is a constant here that is going to allow me to factor this trinomial into a binomial square. All right, so we have to fill this blank in. So remember, it's half of b squared. So locate b, it's negative 4. Divided by 2 is negative 2. Squaring it is plus 4. And we have to make the adjustment and put plus 4 here. All right, factoring here, well, we just fill it up with x, and then it's half of b minus 2. Not the square on b, that was for up here. Yeah, so we're good. Let's see, I don't think I should have put this negative 8 here. I need to come back here and add negative 8 plus 4 So I think I'll go ahead and I think I'll just add the 4 right here instead of just trying to erase all that. But I need the plus 4 here. So let me rewrite the problem to get ready to bring in the square root. And when I rewrite it, I'll go ahead and take care of this. So this is -4. Hopefully you're seeing that when I bring in the square root, I'm going to be square rooting a negative number. And if you remember from the last technique, this is going to give us no solution. So actually, we're finished here. The answer is no solution. So that concludes examples on completing the square. So we need to move to solving by a quadratic formula. I think I could put this all in one video. I think you have some experience with solving by quadratic formula, so I don't think it's going to be too cumbersome. So I think we can do that in the same video. All right, let's solve by quadratic formula. So we need to put that in front of us. All right, so the solutions x will be equal to, it's a big fraction bar, it's opposite b plus or minus, to indicate two solutions, square root of b squared minus 4ac. B squared, whatever b's value is, minus 4, always 4, times the a value times the c value. And this is all over twice a. All right, the one stipulation about solving by quadratic formula is that we have to have the equation in general form. I know it's kind of difficult because you know, different methods require different forms. So solving by factoring in quadratic formula, we have to put the equations in general form, solve for 0. But with extracting square roots and completing the square, to begin with, we don't have to have the equation in general form. They don't have to be solved for 0. So, I mean, I know there's a lot going on. You have to memorize a lot, but we just have to kind of somehow come up with something to keep it straight in our brain. Anyway, here's the quadratic formula. Let's put this equation in general form. The reason being is we have to identify the x, or the a value, the b value, and the c value. So a is 1, b is 3, and c is 8. So I'm going to come over here and underneath here, I'm going to go ahead, since I've got the formula right here to the side, I'm going to go ahead and just start plugging in my values. So opposite b, -3, plus or minus square root of b squared, wrap up 3, square up, minus 4 times a times c. All over 2 times 1, or just simply 2. So the setup is kind of critical, but so is the simplifying. All right, well, our work needs to be done here, so the -3 is good. Go ahead and write that down. Write down what's solid. These are solid. Okay, and then let's work on this right here. So if you have a calculator, just go ahead and find these values, I guess. This would be 9 minus 32. 9 minus 32, -23. Oh, that's nice. We're only looking for real solutions, not imaginary solutions. So in that case, I'm done. I have no solutions. No real solutions anyway, because I have a negative underneath the radical. Ah, that couldn't have worked out any better. All right, let's look at example 2. All right, let's solve this equation by quadratic formula. Well, we need to get it in general form. I could subtract the 4x and pull it over here, but I noticed that the x squared term has a -1 a value, so I'm actually going to move these two terms to the left side of the equation and put the 0 here. So I'd have x squared, the 4x is there already, and bring over the 8, that becomes -8 equals 0. So we're going to solve by quadratic formula. So you guys have it on your notes, but let's go ahead and identify the a and b and c values. So a is 1, b is 4, and c is -8. So x equals opposite b plus minus square root of 4 squared minus 4, part of the formula, a times c. Times all over 2 times a, or just 2. I don't think we're getting as lucky as the last time. So let's go ahead and clean this up. So we've got a -4 here and a 2. And we've got the plus minus. So our work is in here. So that's 16. And a negative times this negative over here is going to be plus. And 4 times 8 is 32. Actually, I'm going to work up here. Save some space. I've got -4 plus or minus. The 2 is going to remain constant. 16 plus 32 is 48. Okay, and we're well on our way. We just need to simplify this right here. And if you spend some time thinking about 48, look for a perfect square factor. Okay, so when I think of the perfect squares, think of 1, 4, 9, 16, 25, etc. Remember, this comes from 1 squared, 2 squared, etc. Okay. If you can think about, does this number 48 contain a factor that's a perfect square? Well, yeah, 16 times 3 gives us 48. So if I broke that into 16 times 3, I'm going to be able to take out a 4, leaving the 3 inside. So I'm going to come up here. So x equals -4 plus or minus, I'll pull out a 4, 4 radical 3, all over 2. Okay, you might be tempted to box that, but we're not quite done, and that's just because there's one final thing you want to do. You want to look for a common factor that'll divide out of this value, any value that's up here, okay, not inside the radical, and then also with the denominator. And 2 is a common factor that divides out. So 2 divides out into 1, this becomes 2, and that becomes 2. So let's clean it up right here. So I have a 1 in the denominator, so I don't need a fraction. The final answer is -2 plus or minus 2 radical 3. If I had more room, I'd write these out as two different solutions, -2 minus 2 radical 3 and -2 plus 2 radical 3. But I've kind of run out of a little bit of room here on this page. Okay, and we're going to do one more, solving by quadratic formula. All right, we're in general form, so we're ready to state the A, B, and C values. These are kind of big numbers. I think there's going to be a lot of simplifying. All right, opposite B. B squared minus 4 times A times C. All over 2 times A, or 40. Yeah. Okay, go ahead and write down the 20 plus minus and the 40 down here. Alright, so this is going to be 400. And it's going to be minus, because there's not another negative to turn this to a plus, so it's going to be minus 4 times 5 is 20. 20 times 20 is 4. Oh, this is nice. $20 plus or minus, we've got the 40 here. This is actually nice. Square root of 0. What a gift. So plus or minus 0, we don't even need that. So your answer is just going to be 20 over 40. We're not going to have two solutions. We're going to have one. So x equals 1/2. That's an interesting case. Glad we did that example. Alright, so those are some examples of solving by quadratic formula. So we saw the last two techniques for solving quadratic equations. We saw, what did we do? We did completing the square, and then we did solve by quadratic formula. So that's all our solving of quadratic equations.